Hey hackers, Blue Cosmo from CCS here. Welcome back to the channel. Today we are covering the next section of the Introduction to Ethical Hacking course. Today we're covering some of the more networking oriented stuff, networking basics, so that way you guys can actually understand some of the stuff we may be doing. Let me actually quickly connect my server in so I can actually show you guys some of the cool stuff we can do with some of the networking stuff. Anyways, let's go ahead and get started. Now, actually, before we do, definitely check out cosmodiumcs.com/courses. There you can check out this course and plenty of other courses that we have taught on the channel before. I'm talking about, Python, cybersecurity, Linux, Wi-Fi Pineapple stuff, Bash Bunny, USB Robotic, a bunch of other cool stuff. So if you're interested in cybersecurity and want to learn more and build your own skill sets, definitely check out those courses. Pretty much all of them are free. So yeah, enjoy. But regardless, let's jump into the video. You can see we are here on networking basics. This is stage 2 of the course, or I guess the third one, because we started from 0. We did 1, and now we're on 2, which is networking basics. Cool. So let's talk about the Internet Protocol address. The Internet Protocol address, also known as the IP address. I'm sure you guys have heard of this before, but it's basically the address of a computer. All right. It's kind of like, the address of your home, how, you can send information to your home based off of your address. It's pretty much the same when it comes to the IP address. It's like the address of the computer. Now, Internet Protocol is the protocol that basically is oriented around the internet, all the computers that are connected across the globe. That gives us, the super cool internet where we can surf around and do some cool stuff. But yeah. Hey hackers, there was a mistake on one of the slides here, so I quickly came in here just to kind of clarify something. So I'm gonna just continue that slide real quick, just that way it makes more sense for you guys. So yes, here we go. So the IP address, right, is the address of the computer, right? But the two types are public and private. Public is a globally identifiable address, right? That is the address that belongs to your router that's routing all the traffic to the rest of your devices on your network. And that's what makes it so globally identifiable, is that it has geolocation tied to it and all this other information, right? Your private IP address is only available to others on the network, right? So it's your IP address that belongs within your Wi-Fi or within your LAN, right? And it doesn't extend outside of that. Cool. So this is what your IP address will look like, right? It's typically some sort of number from 0 to 255, and for representing in each of these X's, and then your IPv6 looks something like that. Your private address will likely share the first 3 octets of one of these, right? So if you're on the network, right, your router will be 192.168.1.1, and then your laptop might be .1.5, and then your TV will be 192.168.1.10, right? Because each octet only goes up from 0 to 25, this network can only go up to 255, right? So there's only 25 or 255 devices that can stay here from 0 all the way to 255. This shortcut is called a subnet, and there's a whole bunch of stuff connected to it. But basically, you'll typically see, here I can open up a terminal, you'll typically see, let me go ahead and make this a little bit easier for you guys to know. This is cool. So if I do if config, right, so that way we can see what network connections we have. You guys can see this is my network, right? And this is my network mask. So this is my 255.255.0.0, right? Yours will probably be 255.255.255.0. And that means that there's this octet's taken, this octet's taken, this octet's taken. But this one is free for the rest of the devices. So that can be holding 0 to 255 devices. Now on my network, it's a little bit different because we have so many devices on this network. So these 2 octets are free, allowing for 255 and 255 available slots in both of those slots. So you can have 10.208.1.10, .2.10, .3.10, .2.15, right? So it allows for a lot more devices on the network. So that's the network mask. The subnet is just what shortcuts multiple addresses into a single subnet. But yeah, so there's something called a subnet, and it's basically where we can shortcut multiple addresses that share octets, right? So similar to how our IP address shares these first 3 octets across the whole network, all the devices on the network will share these first 3 octets, right? The Wi-Fi router, I believe, is .0 or .1, and then all the rest of the devices can be .22, .23, 192.168.1.255, right? Basically, those can be all those devices on the network. Same thing applies to this one, but this one's a little bit less common. It's more common in like corporate areas. But actually look at the subnet cheat sheet, for example. This is provided to us by FreeCodeCamp. Definitely check them out. They have some cool stuff. But we can see this kind of subnet cheat sheet. And the most common one you will see is the /24. So basically it'd be 192.168.1.0/24. And that will basically represent the number of IP addresses, right? So this /24 basically would represent all the IP addresses that are available to us on the network. So this is the most common one we'll typically use to scan. But hey, if you're trying to scan, like the entire internet or something, hey, have fun with this or something like that. But yeah, so that kind of allows you to search or scan or kind of create a subnet or like a kind of grouping of multiple IP addresses. If that's confusing, it can be a little confusing, but just know, hey, this /24 at the end can be used to represent anything that shares the first 3 octets and something else in the 0. Of course, this is linked in the slides and description. This is downloadable on our course, and you guys can learn a little bit more about this by just clicking the link. But moving on, let's talk about ports, right? Ports are basically the area that is allocated on the device to host a process across the network. All right, so ports basically just host services on devices, right? So these ports are basically represented by a number. There's actually only 65,353 ports on a machine. Not all of them are going to be open. Some of them will be closed. If a port is open, it basically means the service on there is enabled. And if the port is closed, that means the service on there is not enabled, right? Again, these are represented by numbers and specified with a colon. So you guys can see, like, this is an example IP address, 192.168.1.22, right? So this is an IP address that is on our local area network. So if we're connected to a Wi-Fi, one of the devices on the Wi-Fi network will have this IP address, and you'll see the colon here to specify this port, 443. If you don't know what this port is, this is the port for HTTPS, which means this IP address is running a website. So if you took our Linux course, right, Introduction to Linux course, you will remember how we started an Apache server. Basically, we can scan the network and see if any of these services are running some sort of web service. So you can actually connect to the IP address the same way we connected to our Apache server in our Linux fundamentals course. But yeah, so networking basics, right? Networking is basically how interconnected computers operate, all right? A protocol is kind of how a protocol is a set of rules that kind of govern how these systems actually communicate. A stack is basically a collection of protocols that work together. We're going to learn about stacks a lot. We're going to get the basics of stacks because they can get kind of confusing kind of quickly. But I'm sure if you guys take along, it's pretty straightforward. So let's go ahead and look at these. So my head is covering part of this, but this section are just ports, right? So these are ports. So let's look at these protocols, right? This is the HTTP protocol. I'm sure if you guys heard of HTTP and HTTPS before. These are the hypertext transfer protocols. This basically allows us to connect to the internet, right? Connect to or access a website. So let's say we find an IP address, right? 192.168.1.24, and then they have port 80 open. If they have port 80 open, that means they have the HTTP open, and that basically means that, hey, we are basically able to say, hey, they have a web server running, but they're having an unsecured web server running. So basically all HTTP traffic is not encrypted. So if we can capture any of that traffic, we can see all the unencrypted traffic there. It's pretty cool. 443, which you guys saw a little bit earlier, is the secure version. So when you guys go on websites, https:// the name of the website.com. This basically is that port. So the IP address of the machine running that server that you're connecting to, it has 443 open, so we can connect to it as a client. FTP is a file transfer protocol. We won't focus too much on this, but it's basically the ability to transfer files between computers. So if we see that a server has port 21 open, we can say, hey, they have FTP. Maybe we might be able to exploit this, maybe see if we can get the credentials somehow, or log in as anonymous, which you may learn if you learn more about FTP. But basically, we know that the server has the ability to transfer files. So let's see if we can get access and transfer files off of the machine onto our computer, right? Those are the type of things you want to look at as a hacker. SSH is secure shell. Basically allows us to remotely access a computer. I actually do have an example of this on my Linux system. I can do SSH, and I know there's a home server in my house, so I'll do ping Cthulhu. Cthulhu is just the host name of the server. So yeah, we can see that this is the IP address of my server. So we can do is SSH into Mythos, which is the username of the computer, right? As hackers, technically we would go for root, right? Unless if we didn't know a username on the computer, then we can specify for 192.168.1.234. This is the format for trying to connect to SSH through our Linux terminal, right? We learned a little bit about this in our Linux fundamentals course. But if we hit enter, it's going to ask us for the password, right? So we have tools to actually brute force SSH, things like Hydra. I think Medusa also are tools that we have, right? You guys can simply just go in your applications, go into pen testing, and then I believe password attacks, and then you guys can see different password attacks, right? Online attacks right there. Hydra and Medusa are tools you guys can use to actually break into SSH service, right? So I already know the password, so I'll just do the password of the computer. Permission denied. All right, I guess I don't know the name of the thing. I would just SSH into a host name because I have an SSH key for it already. So Mythos at Cthulhu. Cthulhu is the name of the computer, so we can still connect to the host name instead of the IP address as well. But there we go. Yeah, so now we have remote access, and you can see we are signed into Mythos at Cthulhu. This is just the name of the server, right? This is the username, and this is the host name. That's going to also be the IP address of the server if you want to. But yeah, now you can see we have remote access into my server through my terminal. I'll just close this connection so that we don't have to worry about it. But that's a cool way that we can get remote connection. And that's just a bash terminal that we have remote connection to onto the server. So if you find a web server that has port 22 open, you get remote access, you can have a remote terminal on the server. So that means all the things you learned in Linux fundamentals, you can apply to that server. So you can actually start services on that server so you can get information off of it, or you can use SCP, different protocols to get information off of it. But that's kind of something that you can do in here as well. TCP. TCP is the transmission control protocol. It's basically what allows computers to actually connect to each other. It's pretty important. You'll learn about the TCP protocol a little bit later. But yeah, transmission control protocol. We'll learn about a lot of this. Actually, you actually scan a lot of networks using TCP as well. So this one, just knowing that it allows computers to connect is pretty important. UDP is the user datagram protocol. It's a little bit faster than TCP, so I'm sure like streaming services and such will use it. But it is a connectionless protocol. This is a connection-oriented protocol, and this is a connectionless protocol. You'll understand what this means a little bit more when we cover the three-way handshake. But for now, just understand that it doesn't use this so-called three-way handshake that we'll learn a little bit. IP, right? We already learned about this internet protocol. It's basically the main networking protocol of the internet. So we don't have to worry about that too much, right? SMTP is the simple mail transfer protocol. It sends emails. It's pretty straightforward. So any email server or email service will often have any of these ports open for simple mail transfer protocol to send mail from computer to computer. Or in some way, FTP is used to send files from computer to computer. The last protocol we'll cover is ARP. This is the Address Resolution Protocol. If you took the Linux Fundamentals course, which was a requirement for this course, you'll know about ARP already, but it is what basically connects an IP address to a media access control address, and that is also referred to as the MAC address. This is super important in Wi-Fi oriented stuff because Wi-Fi does rely on the MAC address of computers. We can even learn how to spoof these MAC addresses, so you can pretend to be, or basically spoofing is kind of like pretending to be something. So if we spoof the MAC address of the router, for example, you could basically pretend to be the router and can trick devices into sending information to your computer and such. It's pretty cool. But yeah, so let's talk about the three-way handshake. I kind of covered about this a little bit earlier, but this is a image from Packet Crafter. Definitely citing them. But we have two machines. We have our source machine, which is our client, and the destination machine, which is pretty much going to be like our server or something. There are three things that get sent between the machines, right? So first is the SYN. The SYN is basically synchronizing, right? So our computer, when we're, let's say we're connecting to a website, we'll say, hey, we'll send the SYN ping, I guess, the SYN packet to the destination machine. Packets are basically what are sent between computers, right? Packets are kind of the information that are sent between computers across the network. Then we can see, hey, this is going to send us an acknowledgement packet, and it will send it back to the source machine saying, hey, we acknowledge you, right? So ACK is acknowledge. Then it will send an ISN back, and this is the initial sequence number. Basically, this three-way handshake will say, hey, I'm trying to connect to you. Go ahead and connect. All right, bet. That's basically what's going to happen. And now they have that connection. So when we are scanning a network, right, and you'll learn more about scanning, but you can hear it in the name, scanning a network, kind of building a map of the network, kind of seeing what devices are on the network. We'll often have our computer basically sending this packet, and then send this packet and this packet. I believe a silent scan will just send this packet and then just wait for that received packet and not make that connection again. But yeah, basically we're sending these packets to see if a machine is on, and then we can even use it to see if specific ports are open as well. But yeah, that's kind of how we do it between these two machines, all right? And of course, this is called the three-way handshake. So let's talk about TCP versus UDP. TCP, right, Transmission Control Protocol. This is, this uses the three-way handshake. It is for standard connections. So example protocols are things like HTTP, FTP, and SSH. All use the TCP handling protocol. Then there's UDP, which is the user datagram protocol. It doesn't use that three-way handshake. So you saw that three-way handshake earlier. This makes TCP a little bit slower because it has to do the handshake and such. But the UDP does not use the handshake, so it is a lot faster than the TCP connection. Yeah, so it's for fast connections, but TCP is a little bit more common, it's a little bit more secure and such. But yeah, so some programs or protocols that use UDP are things like DNS, SNMP, and DHCP. Cool. So let's talk about models, right? So basically, the approach used in networking to create a suite in the form of layered protocol stacks. This is a model. It's basically layered protocol stacks. So remember protocols and stacks from earlier? Yeah. These are kind of implemented into models. So each layer performs a specific operation. We can see these two models that we'll cover today, which is the TCP IP model, which is a 4-layer model. Basically, TCP IP, of course, standing for Transmission Control Protocol / Internet Protocol. It basically incorporates these two protocols into one connection. TCP obviously allowing computers to connect to each other, and the IP allowing us to connect to the internet. So having that in one model is kind of ideal for allowing us to connect to the internet and connect to other machines. So this is a very important model. We'll also see the OSI model. This is a little bit more advanced, so we won't deep dive into the OSI model. But for those, just to have it be a little bit introduced to you guys, this OSI stands for Open Systems Interconnection, and that is an interconnection model. And we can see we actually have a map created by Network Stuff EU, and we can see kind of just a basic information about the OSI model and the TCP model, right? So there's different layers to the stack, right? There's the physical layer, which basically is kind of like all the physical devices on the network. So things like hubs, network cards, and those type of things. Then there's the data link layer, which kind of moves through, connects the physical layer to the network layer. The network layers, the things like routers, and you can kind of see it moves up through the layers, right? Taking some time to learn more about these layers is ideal to definitely build out your ethical hacking skill set. But yeah, so this is kind of like the OSI model. You can see the TCP IP model is a little bit more simple, right? It has the application area, the host-to-host connection through TCP and UDP. We have the internetwork, right? The interconnected network for IP, ARP, and ICMP. And then, of course, we have our initial network access at the bottom. So it kind of just moves through these steps as it goes through. All right, so that's going to be it when it comes to networking oriented stuff. Now in the next section, we're going to cover active reconnaissance and kind of just keep moving through the introduction to ethical hacking course. But again, I appreciate you guys. Hope you guys enjoy this one, and I will see you guys in the next one. So stay happy, stay positive, and as always, happy hacking. Hey hackers, Blue Cosmo from CCS here, and I wanted to introduce you guys to the Happy Hacker Site Plan. The Happy Hacker Site Plan is a plan where you guys can support us for only $1 a month. That's right, $1. With this comes exclusive benefits like courses, articles, videos, and access to our entire cybersecurity knowledge base. If this interests you and you guys want to get access to all this, check out the link in the description. It's only $1, so we definitely appreciate your guys' support. Anyway, enjoy the video and happy hacking.